to what procedure? Partial fractions. That's right, partial fraction decomposition. Now, here comes the question. Is that quadratic factorable? Well, some of you can use the guess and check method, but how do you know if something's factorable? Well, realistically, if we go back to beginning algebra, if we can find factors of a times c that sum to b, it is factorable. And so, Charlie, what's a times c with this? If we're looking at ax squared plus bx plus c, what's a times c?
Negative 9.
Negative 9, that's right. And what are the factors of negative 9 that sum to a positive 8?
9 and negative 1.
A 9 and a negative 1, it is factorable. So you should know it's factorable, okay, Charlie? And so you can use the guess or check method or whatever you want. But how is it factored, Charlie?
3u minus 1.
That's right.
U plus 3.
U plus 3, very good, du. So now we finally got it factored. So what are we going to do now, Charlie?
Partial fraction decomposition.
Partial fraction decomposition, that's right. Okay, so here we go. Well, Charlie, we got a long way to go. All right, so take a quick break here. Okay, we're ready. All right, here we go, Charlie, now. Partial fraction decomposition. We're going to take our rational function there, and we're going to decompose it into fractions with denominators of 3u minus 1 and u plus 3. Now remember, when you do partial fraction decomposition, if your denominator is a first degree, then your numerator must be one less degree, which in this case is a 0, so we'll put a to represent that constant. Remember, a 0-degree polynomial is a constant. Similarly, with the u plus 3, the constant above should be b. We'll let that be b. Now, our goal is to solve for a and b, right, Charlie? Okay, so how are we going to do that?
Multiply both sides by the LCD.
We're going to multiply both sides by the lowest common denominator to clear those fractions out. Or sometimes we like to say, kung fu those fractions. Anyway, okay, so what is our lowest common denominator, Charlie?
3u minus 1 times u plus 3.
That's right, 3u minus 1 times u plus 3. Very nice. So when we multiply both sides, what do we get on the left-hand side, Charlie?
2.
2, that's right. And then we have a times what?
U plus 3.
U plus 3. Very nice, Charlie. And finally, we have b times?
3u minus 1.
3u minus 1. Very nice. Okay, here we go, Charlie. Now, we have to solve for a and b. Now remember, there's two techniques we can use. We can use the elimination method by choosing values of u that will eliminate the a or b, or you can equate terms. Now, this one isn't that tough. We're going to go ahead and eliminate terms by choosing values of u. So here we go, Charlie. So what we're going to first do is we're going to eliminate that a by choosing u equal what, Charlie?
Negative 3.
Negative 3, that's right. And so when we plug that in, we get 2 equals b times what, Charlie? When you plug in negative 3 there, remember it's 3 times u, subtract 1. What do you get?
Negative 10.
Negative 10, very nice, Charlie. So now, solving for b here, okay, what do we get?
Negative 1/5.
Negative 1/5. So we have our b value now. Okay, now, not done yet, Charlie. We got to go for the a value. In order to get the a value, we have to eliminate that b. Now look at the b. b is 3u, subtract 1. What do we have to choose for u to eliminate that b?
1/3.
1/3, that's right. Because 3 times 1/3 will be 1, and 1 subtract 1 is 0. So if we do that, Charlie, left-hand side we get 2, and then we have a times u plus 3. Now, Charlie, if u is 1/3, how much is 1/3 plus 3? Remember, 3 is 9/3.
10/3.
10/3, very nice, Charlie. So a is equal to, solve for a. What do you get, Charlie?
6/10? 3/5?
3/5, that's right. You get 6/10, which reduces to 3/5. All right, Charlie. We finally got our a and b, and now we can go ahead and take our integral and decompose our rational function into two separate fractions, right? And hopefully we can integrate. All right, here we go. So remember, we had a over 3u minus 1, right? And so for the first one, if a was, what was a equal to, Charlie?
3/5.
3/5, that's right. A was 3/5. And so now we're going to take the constant 3/5 out of the integral and write this as 1 over 3u minus 1. Because remember, it was a over 3u minus 1, which is 3/5 over 3u minus 1. So you can take the 3/5 out. Okay, now let's go to our b term. What was b, Charlie?
Negative 1/5.
Negative 1/5. And that would take the 1/5 out. It's a constant. And we have integral of 1 over u plus 3 du. All right, Charlie. So now, we're going to use a technique here to integrate this 3/5 integral of 1 over 3u minus 1. You could do it by doing another substitution, by letting v equal 3u minus 1, but we can avoid that here. Watch. Okay, what I'm going to do, Charlie, is take from the 3/5, I'm going to take that 3 and put it on top of the 3u minus 1, just like that. Because this puts this right into the form of a natural log integral. Because this integral of 3 over 3u minus 1 du is the natural log of the absolute value of 3u minus 1. This is because, notice here, in the denominator, we have 3u minus 1. Charlie, what's the derivative of 3u minus 1?
3 du.
3 du. So it's like integrating 1 over u, okay? And so that is a natural log integral. Now, the second one, we'll go ahead and write that down. That is also a natural log because the denominator is u plus 3, and the derivative of u plus 3 is 1 du. So they're right there, natural log integral forms. Okay, so here we go, Charlie. We're almost home. All right, here we go. We have 1/5. Now, what's the integral of 3 over 3u minus 1 du?
Natural log of the absolute value of 3u minus 1.
Natural log of the absolute value of 3u minus 1. Very nice, Charlie. Now, what's the integral of 1 over u plus 3?
Natural log of the absolute
Natural
value
log
of u plus 3.
of u plus 3, and that's a 1/5. And don't forget, we have to put a what here, Charlie?
C?
Plus c. That's right. Now, Charlie, we're not done yet. That's right. Yeah, this is a long problem. Actually, this problem comes from my version C exam. That's right. Now, the version C exam, that's the exam I give to the students who like to miss class a lot or want to make up a test.
What does C stand for?
Oh, what does the C stand for?
Yeah.
The C stands for see you next semester. Anyway, you don't want the version C exam, so come to class every day. Anyway, let's go ahead and finish this problem, Charlie, because we're not done yet. Okay, what do we have to do, Charlie? We have to replace the u with tangent of x over 2. So here we go. Okay, well, first, we can combine those logarithms, right? Because notice it's 1/5 natural log of absolute value of 3u minus 1, subtract 1/5 natural log of u plus 3 plus c. And remember, the difference of the logs is the log of the quotient. So we can write this as 1/5 natural log of what, Charlie?
3u minus 1 over u plus 3.
That's right, plus c. And now we can finally replace the u with what, Charlie?
Tangent of x over 2.
Tangent of x over 2. So what do we get on top?
3 tangent of x over 2 minus 1.
That's right. And what do we get at the bottom?
Tangent of x over 2 plus 3.
And then don't forget to put plus c. Now, Charlie, we're still not done with this problem. There's still one more thing to do. What is it?
What?
Circle your answer. Very nice there. Now, that was a good warm-up problem. Anyway, we're going to come back later and do some more problems. So anyway, we'll see you all again soon.